Well, hi, thanks for joining me here this morning in my shop. I'm going to be starting the alignment process and maybe even finishing it for this radio today. So first thing we're going to do is do the alignment of the intermediate frequency stages or intermediate frequency transformers. They're in these two cans at the back here. And to do that I have to feed in a known signal, 455 kilohertz, and then measure either the level of volume coming out of the speaker, or in my case I'm going to keep track of the AVC voltage on this meter. There we go. And then it's just a matter of twiddling 4 screws on the top there. Let's take a little bit of a higher view of things. Maybe not that high. There we go. Good. You can see the meter and you can see the radio. You can see what I'm going to be doing. Let's flip on the radio. There we go. Give it the full shot. You can see the connection of the signal generators just made to the antenna. That's not necessarily the best way to try to feed 455 into a radio like this. There are better ways, but I'm going to try just shoving it in through the antenna and see if any of that makes it through the IF or not. I'm pretty sure it will. Yeah, there's something a little odd going on with my signal generator there. What's with the numbers? I don't think I've ever seen it do that before. Something out of sorts here. Uh-oh. You know, if it isn't one thing, it's always something else in my shop here. I don't know why it's doing that. I've never seen that before. Yeah, it's a modulation off. That's the output cord off. Was it the counter or is it my... No. Son of a gun. Everything's breaking down on me. I don't know what to do about this. This is let's put it on a different frequency counter and see if the other one shows the same unfortunate thing. Oh my gosh. Right away? Oh boy, 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 boy. Some nice individual in California is mailing me up another signal generator identical to my B&K sweep generator, which is right here, which has also started acting up in the last week. So what we're going to do though is we're going to connect to this counter here and just see what it counts. Son of a gun. I got more problems now. Oh no. This just came loose. Son of a gun. Ew. Well, things have gone downhill rapidly here in Jim's shop right off the bat. I am all messed up. Well, one thing to notice is my other frequency counter is stable when there's no signal fed into it. Why won't this one count here? Come on. It seems to be jumping all over the place. Man, oh man. Oh, this is going to break right off here. I'm not careful. Son of a gun. Yes, if I wasn't videoing this, I would use other words at this point. Oh, baby. Okay, let's try right out of the output of the signal generator here. Right out of there, right into here. Can't imagine it would be any different, but let's find out. How about there isn't enough juice to drive my... So there's this is the usual output you use for taking the controlled signal, controlled by different controls here, but there's a much more powerful one right here, which is the one I use to drive the counter. So let's go up there. Son of a gun, we're going even. We're just going down, 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 down into misery. Okay, let's just try to minimize the level of despair here. Put this back on in hopes that somehow it's just come back to normal. Wow. I see what's wrong. I see what's wrong. Do you see what's wrong? It just doesn't get any more embarrassing than this. I mean, you should turn it on. Oh my God. Oh my God. Okay. Well, call it a lesson learned. Okay, good news is absolutely nothing is wrong here except me. Once again. Oh boy. Okay. That was fun. Okay, now let me settle myself down. We want to put 455. It just must have been some wild coincidence that this thing was showing roughly the right frequency at the start there. I don't get it. So there's 455. Dial it just a touch low. My counter's just a touch off. That'll be 455 good enough. The signal level fairly low. Feed it into the radio. Okay, we've gotten somewhere. Let's listen to the radio. Now up the strength of the 455 until we start to hear it. And then again, maybe we're not going to hear it. Okay, so that little plan of sneaking it in through the antenna has not worked. So our next potential place to stick it in would be... I'm a little stunned this didn't work. Just back up a minute here. How come this wouldn't work? Because we're on AM and I have it hooked up to the shortwave input. I think that's probably the catch. So... let's put it. Yeah, let's feed it into there. That's the problem. That's what I've done. In fact, I never even tested this radio on shortwave since I've changed the capacitors in it. But testing it even on the AM band still pretty thoroughly tests the radio. Okay, is that going to stay there? I think so. Let's see if we hear it now. Ah, yeah, okay. There we are. That makes a little more sense. The hurdles come, the hurdles get jumped. Okay. Now, I see this is way off calibration here. Okay, that's 30% modulation it's showing. Now I've lost it. Okay, so I'm just trying to get the levels right so we can hear it, and it's not so high that it's driving the ABC. Full tilt. Let's see what we got now. ABC voltage. Yeah, you can see it on the meter. Tuning the radio won't affect this anymore, but tuning the signal generator will. If I remember right, it was wasn't it 443 it was actually tuned to? So keep your eye on the numbers here and watch for the peak happens. Oh yeah. So right now the IF is tuned to 442, and it should be 455. And that will cause the pointer to land in the wrong spot on the dial. So we're going to correct this. Unfortunately, we can still hear it at 455. A strong enough signal going in the radio, we can still hear it. And that means it'll be easy for me to tune it up. So let's do the tuning up. Just need the right screwdriver. Okay. The capacitor screws on the top. You can use a metal screwdriver. If you're lucky, you can test it. You say, does this do anything? Touching it? No. Doesn't change anything, so the metal of the screwdriver doesn't matter. What you get with that is a perfectly stiff shaft, which really makes doing this far better. So we start on the one that's closer to the speaker, the second IF. I'm going to watch this meter. It's going to come up quite a bit while we do this. On some of these screws. That wasn't too far off. Maybe these are all tuned to 443, or maybe only one or two of them. That's a little better. So as the ABC voltage comes up, the amplification through the front end amplifiers gets less, and consequently the noise you hear gets less. ABC causing the amplification to be reduced. Here we go. Excellent. Now this may not make the radio any louder, it's just really ultimately going to change the position of the pointer. On the other hand, if these four things I'm tuning weren't all tuned exactly the same to whatever, 443 or 455, then they won't be efficient in passing the signal. They all got to be lined up somewhere. 455 being the proper place. So it looks to me like these are kind of all over the map. Go back over them now. These affect the tone coming out of the speaker too. You can get these two tuned up on some radios, and narrow the bandwidth in the intermediate stage, and you end up losing the highs, the higher tones. The risk of letting the higher tones through is you're going to let a little more noise through at those higher frequencies. That's why radios come with a tone control, so the operator can decide for himself. In fact, the tone control on here is set, I think it's set for low tone. Let's move it up. Where's the switch? Here it is. Yeah, okay, you should really be doing this with the tone open. What happened here? How come that's not moving? Oh, that's right, it's ABC, not volume. That's a good reason. So, one last time through, because I was talking too much while I was doing it. Pretty interesting how the video allows very strange time effects. You're watching this video, you're seeing me do this, and I'm being extra careful because I know you're watching. But you're not watching while I'm doing it. I'm kind of in the future at the same time I'm here now. There we are. That's not going to get any better. So there we are, 455. Yep, signal counter still showing 455. So that's the first stage of the alignment. So that may have boosted the radio's signal a little bit coming out of the speaker, make it a little stronger. Increased, may have altered the bandwidth of the IF, which may have been inappropriate, and will have corrected any pointer errors, aside from the fact that there's other things that affect the position of the pointer, namely the next thing we're going to try, which is the local oscillator. On this radio, because the front dial face excuse me, the front dial face is missing. There's one winding its way here now through the mail from the United States. It doesn't have any dial markings, but these radios come with, on the back of the capacitor, a chart. The back of the tuning capacitor. And the alignment instructions are based on this chart. So we're going to carry on using the chart. First thing I have to do is arrange a pointer, a temporary pointer, to point at this scale. I shouldn't say chart, I should say scale. So that's what I'm going to do. I get all that ready. I have to get the alignment instructions out on the screen and all that stuff. Good so far. Okay, so I'm in the last steps here of putting in the temporary pointer, that little piece of wire there. So I have the capacitor all the way one way, right? And then I just need to line up the pointer with this 0 mark on the scale. I want to get this right up against the scale so there's very little parallax. Oh, that's pretty good. So move it over a touch. Man, that looks pretty good. Okay, let's try the other end. So if I'd aligned it starting at this end, I'd actually have it in a slightly different position. It's a little odd, isn't it? It's not exactly. Well, I'm going to guess 0 is a better place to start. If we do this wrong, then the pointer on the front won't line up with the scale. And in fact, no matter how carefully we do this, when the scale comes, we'll have to recompare it and maybe make more adjustments. But the adjustments will be easily made at that point. And what adjustments are we making? Okay, so we're going to be adjusting these 3 coils here, slugs in coils. There's one capacitor up here, and is that it? 4 things? Maybe there's something up underneath. Hopefully not. Good. Okay, got to study up on the. Let's take a look at the alignment instructions here. Okay, so here's a layout of the radio chassis, and there's the capacitor that gets adjusted here, and then the 3 slugs, and then 2 more things right on the front. There's holes on the front apron that give you access to a couple of more trimmer capacitors here. So that's 1, 2, 3, 4, 5, 6 things that need to be adjusted at this point. Just looking everything over here. Sometimes there's a capacitor on the antenna that needs to be tuned, but not in this case. It's located on the radio. Great. Anything else here? No, I don't think so. So let's see what it has to say. Alignment procedure. I'm just going to read through this. So now these are all pretty similar, but never identical. So you really need to look at the specifics for the radio you're on. Cathode ray alignment is the preferable method. Connections for the oscillograph are shown in the schematic diagram. We saw that earlier. Output meter alignment. If this method is used, connect the meter across the voice coil. Turn the receiver volume control to maximum. Test oscillator. For all alignment operations, connect the low side of the test oscillator ground terminal. Keep the output as low as possible to avoid AVC. Now, if the AVC starts operating, it just becomes more and more tricky for you to spot the peak point. Calibration scale on indicator drive cord drum. So that's what I was putting the pointer up against. Tuning dial is fastened in the cabinet, cannot be used for reference during alignment. Therefore, a calibration scale is attached to the rear of the drum, is mounted on the shaft of the gain condenser. The setting of the gain condenser is read on the scale, which is calibrated in degrees. The correct setting of the gain in degrees for each alignment frequency is given in the alignment table. So if you look over here, we will see somewhere, here we are right here. These 27 degrees, 93. This is telling you how far to turn the gain condenser. As the first step in RF alignment, check the position of the drum. The 180 degree mark on the drum must be in a vertical position. When the plates are fully meshed, the drum is held to the shaft by means of 2 screws and corrected if it needs to be corrected. Pointer for the calibration. Improvising a pointer for the calibration scale by fastening a piece of wire to the gain condenser frame. That might actually make a touch more sense than what I did, because the frame of the gain condenser is supported on rubber mounts and can move a bit. So the condenser and the wheel move together. So if you put your pointer on the condenser, it's going to not move relative to the wheel. Now, I haven't done that, but I don't think it's going to cause a problem. We should really check this though, 180 degrees point. And we will do that. Band spread alignment. The most satisfactory method of aligning or checking the band spread ranges is on actual reception of shortwave stations. This is because back in the day, the signal generators were not accurate on their dials, and nobody had digital frequency counters. So how do you know for sure your signal coming out of your signal generator is right on the money? You can't know. So you listen to radio stations trusting that they are on the frequency they claim to be on, and of course they are. So that becomes your better way of doing it back in the day, but this is not true today anymore. In exceptional cases, the set is being serviced at a location where noise level is high enough to prevent reception. Test oscillator may be used with a high degree of accuracy, and that's what I've got here. Determine the exact dial settings of the test oscillator by zero beating, you got bearing, it should be beating, zero beating the test oscillator against the shortwave stations. So what they're saying here is you can verify and adjust your test signal oscillator by comparing it against radio stations. Use of harmonics for the standard broadcast range of a test oscillator. Okay, so we're not going to do anything with harmonics. Test oscillators and point band spread. Final check should be made. The reason they keep saying band spread alignment is because in a band spread radio, where the band has been spread across the dial, accuracy and precision is possible. In a non-spread band radio, where they've got 10 megahertz on the band dial to go across, accuracy becomes much less critical. So that's why they keep saying in the band spread alignment. Final check should be made, actual reception. Chassis fastened in the cabinet, pointer accurately aligned to the dial. All final adjustments. Well, we will do that finally, but I think we're almost ready to go here. Really didn't make any explanation of, so you're using your cathode ray scope. How's that help over an output meter? So I think the deal could be cathode ray scopes came with high impedance inputs, whereas meters did not. Now you could be using like I am, using electronic meters, VTBMs and that, and then you could use it fine. I don't quite see the advantage here, but they're not telling you to do what I've done right now, which is I'm using a voltmeter to measure the AVC. But I know the input impedance is very, very high. So when you're reading these things, you have to think back to what the situation was for the people back in the day who were reading this stuff, and not the people in the factory who had all the equipment, all the engineers and technicians in the factory. This is some poor schmo in his poorly lit shop with a big 15-pound soldering iron trying to fix this radio. That's what's really going on here. So that's what this is written for. Written for those guys. So let's see what it says here. So we've done this. So I like that. This is telling you pump it right in through the antenna, just as I did, but put this fake little antenna capacitor in there. I don't think I did that. I'm not going to worry about it though. Did all that. Antenna terminal 300 ohms. 1400 is where we start. Well, let's find out what happens. So we'll set this up. 1400 should occur at 27 degrees. Well, let's just do that and see what we get out of it. 1400. Okay, here we go. 1400. Huh, 1400, bingo. No, it's 88,888. Presto! Did you see that? That's one of my best repair efforts ever done. Just like that. That's like the Midas touch, you know. That's 1400. Now we're going to tune in. 1400, that's a stupidly strong signal. Should easily pick that up. 1400. 1400. Let's spin this around. Oops. Not sure why though. Why did it get quieter there? Not sure what's happening. Okay, there we go. 1400. Huh, it's just the antenna. Maybe it's picking up this. Some kind of effect there. Oh, it's my hand. Okay, never mind all that. 1400. 1400 should be about here, I think. There it is. It's got a chunk of noise right on top of it there. Let's just go to a quiet spot. We can't do that. We need to be on 1400. Okay, 1400. And I'm going to take a moment. I'm going to arrange my camera back here to be looking at the scale. So give me a moment to get that set up. Okay, I think I got this set up nicely now. You can see the camera positioned right here, and you can see, the results here on the screen. And it's lined up so parallax is minimal as best I could. It's not quite 100%, but it's not too bad. So 27 was where this was supposed to be found. Where'd it go? Let me give it a little more power here. Make it obvious where. Not very obvious at all. Oh, I got the modulation on this. What's happening here? Put it at 1000. This is showing the modulation up at 30. Oh, I'm stunned we can't hear that. Maybe I got this down too low. That's probably what it is. Not enough. Okay, uncalibrated signal of some number of, in that case, probably a millivolt, 1000 microvolts or something like that. Coming up here. Come on. Where are you? There it is, finally. Okay. So, 1400. is showing up at 23 when it should be way up here. It should be up here at 27. Okay, let me just peek at those instructions myself here. What about the other end? So the other end should be, oh, they don't give another end. That's interesting. If you just do the AM scale here at 1400, set it with the local oscillator, and leave it. You don't do both ends. Well, we're here. We might as well do this. Let's do this. So we set this. We want it to be able to pick up this tone at 27 degrees by adjusting C22, and C22 is on the front of the radio hole closest to the speaker, or more central hole. Okay, sorry, I'm just looking at the. Here I am. Come back. What am I doing? Help me! Help me! Okay. Lost in my video stuff there. Okay, here we go. So the hole, that's the hole down there. And look through the hole, there's a capacitor right inside. So the objective now is to have this radio pick this tone up at 27. Go ahead. I got a very strong tone here, so we'll have to tone it down a little bit. 27. We head that way. Make it louder. Whoop. Oh, something seemed to jump there. No, I think maybe it's just a little fast. Okay, 27. And, I'm still worried there's a bit of a parallax thing happening there. It's so dark I can't see. Too dark back there. Okay, hang on. We'll change the lighting scheme here. And put a little more light on it. There. Now, if I could use the light and the shadow here to help out, but they're not lined up. They'd be lined up if I did this, though. If I can't get the camera in line, maybe I can get the shadow to line up. So the camera should really be over here. And shadow lineup would be something like that. Yeah, it's all lining up on 27. You know what? In the end, I got to do this again anyway when the final scale is on the front of the radio. So for now, that's going to be just fine. So there we are. Another issue is the position of the pointer on the string. You can slide the pointer back and forth on the string. And I have the feeling, unless they put a mark here on this panel, and I haven't noticed any, you'd have to do the pointer line up when the set is back in the radio with the proper scale on the front. It didn't say anything in the instructions about that, did it? Not that I saw. So we won't worry about it because right now the pointer position actually is not critical. It's all about what's back here. What's back behind it there on the scale. So that's it. No, but there's a front end issue on the that needs to be done. Well, let's take a look at that. Let's jump and take a look. Take a look. Front end issues. And really a poor choice of words. The next step is this one here, C1, which is the antenna. We've done it 47. Radiated signal. So what they want you to do, how do they do it? Radiation loop comprised 2 turns of wire 18 inches in diameter, should be connected to a test oscillator 4 feet before adjusting C1. Okay, radiation loop. All adjustments indicated above, I should have read these notes, shouldn't I? Except operation 4 are made with antenna link in the open position. Oh, lucky me, it is open. Now I gotta close it, engage the loop antenna, and then use this radiation loop. And 1400, and just adjust the C1. Now where is C1? C1's right on top here. So adjusting C1. 1400. Radiated signal. 4 feet away. Okay, there we go. Okay, I'm going to knock down the signal generator. Okay, double check to make sure we're, yep, ABC generated. It's just right on the limits of my meter scale. I'd rather have it sitting in the middle. Let's go lower. That's really not going to work too well. I'm watching the meter, I'm listening to it. The sound sounds better here, but the AVC is higher back here. That's interesting. Let's stick with the AVC. There's some kind of noise that's making the meter bounce up and down here. So to get rid of that, to boost the output of the signal generator, yeah, let's do this. We're just not getting good enough here. Darn it. So it's either the meter either wants to be here or over here. I can't seem to find a spot in the middle for it. Well, let's go ahead. See what happens anyway. Even though we're up near the top range. Does a metal screwdriver affect it? Seems to. Definitely affects it. This is a big metal screwdriver. A small metal screwdriver. It's quite likely to affect it here. Not enough to worry about. Here we go, turning. Oh boy. So what's happening in this case is, as I apply a bit of pressure with my hand to turn the screw, I'm affecting the very thing I'm trying to adjust. Got to do this without pushing down. And wow, there's almost nothing happening. There it goes. It just isn't working right. I gotta get it in the middle of the scale. Doesn't want to go. I won't do it. I'm going to turn this to where it sounds like it's tuned properly, even though the pointer's a touch low. Let's just see if this will bring it up. Down. Down. The top is there. Not exactly sure why the sound is not matching the peak on the meter. Because if I didn't watch the meter, I would tune the radio. I would tune it about there. That's where the ABC wants to be. Sure sounds like something not lined up quite right. Okay, we're just doing this kind of roughly anyway, because I have to do it again later. Don't forget that. Now, to the shortwave band. First time I've really checked this part out. So, let's jump and take a look at the instructions. We'll follow the instructions here. Shortwave band. We go on the antenna terminal, open up the antenna link, go on the antenna terminal, use a 300 ohm resistor in series. The reason for this is that the radio is imagining an open wire antenna hanging out the back of it, maybe going out into your backyard. And the resistance, the apparent impedance of a wire like that is somewhere in the range of 200, 300, maybe 400 ohms. Maybe a little lower, maybe a little higher. The test equipment typically presents a 50 ohm impedance if you hook it up to antenna terminals. So what they're saying here is you want to try to mimic the antenna. Stick a 300 ohm resistor in there. So that's what we'll do. First thing we do is 15200, which is at 93 degrees. 15200, 93 degrees, 300 ohm resistor. Got it. Excuse me. Remnants of my cold here. Ground on ground. Ground, the same thing as this. Okay. Now we're going to flip to AM. Or, sorry, flip to shortwave. What am I saying? So I flip to the shortwave band. I think I'm on the lowest frequency band. Okay, we're on the highest frequency band now. Let me turn it up here a bit. Ooh. That's not quite what you want to hear. Maybe we got more problems to sort out in this radio. I've kind of ignored the shortwave to this point. Okay, tuning should be, what was it, 93 degrees. Okay, so we'll go to 93. That's 90. 93, so around here. And what was it, 15 something. What's that, 15? Well, we'll just tune around 15 until the radio picks it up. We'll turn this back one notch, maybe 2 notches. And up to 15. Here we go. Oh, I didn't hear a thing. Whoop. Didn't hear a thing. Let's go a little more power. Nothing. Okay. Did I hook it up? I hooked it up. Let's give it the works. Powie. Virtually any radio that's working to any degree will pick this up with this signal strength. So either I'm not on the band, I think I'm on, or once again this radio is suggesting it's just doing nothing in shortwave. So let me check the band issue. To do that, I need to run out and look at the cabinet to be sure. Okay, I'm going to go take a peek at the cabinet. Okay, so we're definitely on the 19 meter band, and we should be picking this up. What else could be incorrect here? I just don't think anything's incorrect. Okay, well, it doesn't want to work on that band. Let's try another band here. We could try the 25 meter band at 11.8. Okay, I'll snap back one band. Let me turn the volume down here, just in case we hit the mark. Okay, back one band. Oh, dirty switch. You dirty, filthy switch. Let's go back to the top one. A little more volume here. Look at that. If I turn it, hold it a bit. There. Sounds like it's working now. Okay. Can we find it? Let's get this back. Oh yeah. Oh yeah. Oh yeah. Oh yeah. So that's the problem. So we are at, what frequency are we at? We're supposed to be at 93. That's where it's tuned. 93 is supposed to give you 15.2. Look at that. Wow, that's pretty good. How do you like that? Dirty switch. Okay, we got to deal with the dirty switch. You dirty switch. I was watching some old gangster movies on the old movie channel yesterday. Sometimes these old movies catch my attention when I flip by them on TV because the acting sometimes is really pretty good. Yeah. Okay. So the switch. Now that's something maybe I could have dealt with once again earlier on in the scheme of things, but I generally go by indications. You know, something has to trigger me to take a step. So the switch is up here. Oops, up here. We'll take a close look at it. I just use the camera as it is. I'm not going to be able to see much here, I don't think. Especially if I can steady this up. And it's your basic switch. So we're just going to spray some cleaner in there. A couple of old capacitors that I don't intend on changing. Nothing spectacular. So I'm going to you can see a little black on it there. Probably a tarry sort of tarish sort of black material. Okay, we'll hit it first with contact cleaner. Let her rip in there. I had set a radio on fire doing this with the radio operating, throwing the switch back and forth. I started a small fire in it once. Now I find this stuff tends to drive off everything that's making the switch kind of lubricated. The dirt has kind of a lubricating effect on it. So I'm liable to throw, oh my god, no, WD-40 in there. I like to do these with the radio operating. I'm not in this case because then you can hear the benefit if it's coming. I can definitely feel a change in the switch though. It's toughened up. The surfaces aren't sliding as smoothly. You know, it's much more like metal kind of grinding across metal. It's kind of what it feels like. Maybe that's what it's supposed to feel like. Okay, we ready? Switch on. Any fire? Any flame? Any fire? No. My fire extinguisher is 5 steps outside my shop. Okay, so based on hearing nice hiss, not so good. Let's turn it up. No? Look at that. It still sounds the same. In fact, I kind of killed it here. Oh my gosh. Radios can sound like this when they have no antenna hooked up. Yeah, I've got a signal generator hooked up, but that's not a good. That's not a good. Let's put a good on there. Okay, so this is an antenna from outside. Maybe not right now. That didn't make any difference at all. So this is the output level control for my signal generator, and it works by a factor of 10 every time I snap it. Right now it's times 10. This is set roughly to 10 microvolts. So 10 microvolts times 100 gives you 1,000 microvolts, 1 millivolt. So we should know there's 1 millivolt here. What's arriving at the radio? It'd be something close to 1 millivolt. And the radio can hear it. Very good shortwave radios can hear 1,000th this signal strength. So this guy's not doing so well, but he's there. So the question becomes, why? Why is he not doing very well? Alignment issue? We'll take a shot at that. The alignment step here, you know what? They're all oscillator alignments except for C4 on this band. So let's try that. C4, and C4 is the other one at the front. Okay, I'm not sure this is going to help, but let's give it a try. C4. C4 will be this one. Just randomly kind of. You see, I'm eliminating the capacitance. I got it cranked right out. Seemed to get louder to me. Go back in. And practically kill it. Now, is it because it's moving? Shouldn't. No, it's killing it. So why does this trimmer capacitor need to be wide open? Something's amiss. I think something's amiss in the radio. Let's try the antenna on this band. We know it's got some sensitivity. I still have not fixed my antenna after part of it fell down and okay. This time of day we could pick something up here. It's quite possible. There's that dirt spot. Anything would help. It's not going to do it. So we don't know for sure there's anything there to be heard. Short. Oh. Yeah, 911. Let's try this. This is a good chance we'll get something on this band. Come on. Brother Stare. Come on, man. Come through. Have to get another shortwave radio to find out if there's anything there today to receive, because sometimes the conditions are so bad. We're back up on the 19 meter band. 20 megahertz. Well, dirty parts up here. How can that be? Okay, well, you know, good result on the AM. Actually, we don't even know what the result on the AM was. Let's find that out. Okay, AM with the radio on its side. Okay, high end, you shouldn't expect to pick anything up here. French station's coming up. The antenna may not be aimed right though. Getting quieter? No? Maybe? Sounds like it's getting quieter. Hey, where is everything? Holy smokes. Okay, let me switch off for a moment. Take this out of here. The AM antenna is not connected. That's probably why that didn't work. I'm pretty sure I gotta close the link. Hang it back here. So the radio's been operating long enough now. I'm starting to get an idea how hot the power transformer will get. It's pretty warm. That's pretty warm. That's normal though. Take all this stuff off of here. Close the link. I'm not sure you really need it closed for AM. I don't think so. Study that schematic some more. Come around, radio. Okay. Let's try it again. One last try here for today, and then I'm going to have to consider what has happened to the shortwave bands. It's never worked since I've had this radio in my shop. Every time I have tried shortwave, it's been a no-go. I think that's 590. Wow, okay. Unfortunately, there's some interference coming right on top of some of the stations I like to listen to. Well, performance doesn't seem to be better. It seems to be a little worse than it was. Ay. That's okay. That's only a first time through. Besides, we're going to focus now on how come this guy is so weak on shortwave. And, you know, it may be a tube. It may be the very first tube in the radio. Just can't do it anymore. I don't know. We'll find out. We'll find out on the next video. Thanks for watching, and we'll see ya.